The title is a little bit of a misnomer. Go Get Better kind of assumes that you know Go, and the blurb for this talk is like beginners. Actually, the Go Get Better is helping me get better at Go, because in order to teach something, you actually have to understand it quite well. I have a good handle on Go, and hopefully, between me showing you how some of this stuff works and questions that you ask me, we can all get a much better appreciation for the language, including myself. So this should hopefully be a training course for all of us. This is taken from a 3-day course, shrunk somewhat, and is really just to give you a taster of what's going on. If you're interested in all this stuff, the online course that Go provide themselves was wonderful. So we need a Go file. So we go new Go file, and we shall call this hello.go, because you know what's coming next. Now, on top of Go file, you have a package directive, and the package directive tells you what package you're in. Already, I'm regretting my choice of folder name, because you can't use a dash in your package name. It has to be an underscore. And in general, your package name wants to match the folder you're in. It doesn't have to, but you're setting yourself up for problems. However, we don't want a normal package. We want a special package, because this is our program entry point. We want package main. This says that it's going to be an executable that we can run. So in Go, we have functions, func, and then in keeping with the common thing, func main takes, can anyone guess? Nothing. Now, at this point, people may be thinking your braces are in the wrong place. No, they're not. Go is an incredibly opinionated language. There is one way of doing things, and the compiler enforces it. This is not a language to express your inner artist. And I disagree with some of the things that Go makes me do, but the compiler says tough, and my choices are do it the way the compiler wants me to do, or use a different language. So my braces are in the correct place. And then at this point, we're going to use one of the built-ins, so println, and we're going to open some quotes, and instantly I have a huge dilemma, because I can never remember if it's hello, comma, world, or hello, no comma, world. No comma. Right. Excellent. There we go. We'll split the difference. Hello. Well, so I'm in an IDE, and we can do all kinds of fun things where I can just hit the play button. Why nothing here? Oh, I know why. Duh. This is a brand new Go package. I haven't told it anything about what's going on. Just like you need to init your Git repository, I need to go init my package. And at this point, you need to know a little bit more about the packaging structure, because it's not just the directory in it. It counts directories above it as well. A little bit like Java does with its class paths and what have you. So we're actually going to be going from github.com.davis. This is the directory path it's in, ACCU 2019. And this format allows it to actually go find code in distributed VCS repository. So if you've got something in GitHub and you've got the package name of github.com, whatever, it knows where to go get things. So I can now initialize. Oh no, what have I done here? What version of Go am I actually running on? As is always the case. Oh, I know why. This is one of these things that you only run occasionally. Go mod in it. It's the Go module support. Yoy, Excellent. My first rule of typing is that typing ability is inversely proportional to the number of people who are watching you. Yes. Creating a new module. Right, so also IntelliJ is whinging at me and saying I need to enable Go support, and now hopefully I should have run. Mana. We have a program. Now Go is a compiled language, so we can actually go build, and it will go off and build, and then we should have something called ACCU 2019. This is a Mac, so it doesn't have extensions for the binary names. So ACCU 2019, off we go. We can also, if we are not wanting to rebuild our program each time, use go run, and then hello.go, and that will compile it and run the output, so compile it in a temporary place. So we have code, we have a question. That big in bytes. So it's statically linked. If you care about the minutiae of performance and stuff, Go is probably the wrong language for you. If you want something that's nice and fast to compile and runs reasonably okay-ish code, then it's a wonderful language. So, hello world doesn't really get us a huge amount of distance. I mean, we've just seen using word file systems, and now we're back here. So we probably want to do something a little bit more adventurous. So where are we? For loops. They're very similar. Now, Go has an interesting method of assigning things. You can term any of a variable. You can say var s is a string, and if you're doing this outside of a function, you will always do either var or const, the variable name and the type, unless the compiler can work out the type, because that is always going to be a string. It knows it's a string, and in fact, in this case, it wants to be a const. Now, for all of you people who are worried about whether your const is east const or west const, the compiler has your back here. It's west const. If you are inside a function, you can use this shorthand notation. So the colon equals, which is basically shorthand for var, whatever. And then we're going to start off with I1. We're going to limit this a little bit, so to 19. None of this should be too I++ braces in there. Now you'll notice I don't have parentheses around the arguments of the for loop. Go doesn't use parentheses in ifs and fors, which takes a little bit of getting used to, but then starts feeling very normal. Then we can turn around and we can say if I modulo 15 is 1, let's set our random number seed to 176.06.4004. Hopefully we'll know where that number comes from. Now we're not going to be using the built-in anymore. We're going to import from the format package, and we're going to use println from there. Actually, we're just going to use print. Now, the observant among you will notice that we've now gone uppercase with our print. Before it was print or println lowercase, now it's uppercase. And this is because Go actually uses the case of function names to work out their visibility. So if they are lowercase, they are only visible within that package. And if they're uppercase, they are effectively public. So if you're from a Java background, it's package scope and public scope, which takes a little bit of getting used to, but again, it starts becoming quite natural and normal. And then we're going to do a slice of strings. Now, Go does have arrays. We very rarely use them. Arrays are fixed length. Slices are much more dynamic and sit on top of arrays. And again, we're going to do a format.sprintf. Hopefully I don't have to explain what that means in this crowd. %d I. Then we're going to turn around here and we're going to go. Any guesses for the next word that's going to come? No. Fizz. Then buzz. And then fizz buzz. And then we're doing a round in 63 because of course we are. Now you have Kevin and Henry to blame for this. 4. Right. Is this going to work? Well, looks like it's worked. So if I am ever in an interview with any of you doing a Go job and you ask me, please implement FizzBuzz, this is the way I'm doing it because that is a bad interview question. So the reason why this works is actually that random seed puts us in the correct space in order to produce a set known output, which allows us to then select within this slice of string whether we want to print out the number that we have, which is this one here, or whether we want to print out a fizz or a buzz or a fizz buzz, and doing a round in 63 and then modulo 4 on that is what's doing that. The reason why we're doing %d here is because if we try, a lot of people going through the course will try and do that. And let's just stop from whinging. So, stop from whinging even more. The underscore character, Go will not allow you to not use a variable. But sometimes you don't want to use the variable. So the underscore character says, I know there's output here, I don't care. Throw it away. Now that doesn't have the effect that everyone thinks. What that actually does is it turns around and says, give me the ASCII character for that particular digit. And when we're doing these training courses, we go through, generally from 1 to 100, and it spits out a bunch of control codes onto the terminal, and it's very interesting and fun, and you have to close the terminal because it's very hard to get back. And so this is why we're doing the format sprintf. There's also other ways you can convert ints to strings. Now, arguably, this is brittle. They might change the random number generator, and they have actually done things like that. So if you are iterating through a map, it used to come back in a deterministic order, although it's not guaranteed to. So now it is actually guaranteed to come back in a random order to stop a particular class of bug with smaller maps. So let's do a slightly less, let's get my cheat sheet up, slightly less bonkers type solution. So we'll keep this up here, and we will introduce our pattern, which is a slice of int, and it's 0, 0, 1, 0, 2, 1, 0, 0, 1, 2, 0, 1, 0, 0, 3. So we then need to use the pattern. It's down here. Again, typing ability. What's going on there? There's more stuff to be. This is annoying. We have a small amount of space. I'll try and balance that there. Disaster looms. So we're pulling out, I know why. Because we're pulling out the pattern of that. Not even the pattern of that. Oops. I minus 1. Modulo 15. Dunk, dunk, dunk. Dunk. Excellent. Go away. And that has also run exactly as we wanted to. And we can actually show that running. If we increase the number it's going to, let's go to 20, and we should get one more out. Bing. Right. So that is, of course, a much more sensible implementation of FizzBuzz. for a given definition of sensible, except we don't necessarily have to go through our slice this way. Go actually allows you to range. So we can do for I range pattern. I'm actually going to get rid of this just for the time being. We'll move away from fizzbuzz just for a while. Who can tell me what that's going to output? No guesses? No, that will actually work. Well done. Points to that man. It's actually their indexes. Go allows for multiple returns. So you can actually have multiple things returned from a function, or in this case, range. So when you're ranging over a slice, or indeed a map, you get two values back. Now, unlike user-defined functions, the built-in stuff allows you to not bother about the second parameter, which I hate, because the amount of bugs that this introduces where you think you've got your item and you've actually got your index is annoying. What we actually want is this, which will then print out that. So, and if we wanted to, we could do like this. And off we go. Dun, dun, dun. So that's got both of them going through. So I've mentioned maps a few times. We've had a quick look at slices. So we can create a I don't want to slice at all. So I've got a touch bar, and I've mapped the key in the top corner to the least destructive thing that if you just accidentally touch it. So we want a map of type. No, let's just get a string. So what we're saying here is we have a map. The key value is a string, and the value is also a string. There are some limitations on what you can use for the key. It has to be able to do equals and various other operations on it. Although the list isn't that onerous, and if you're trying to do stuff like that, you're kind of doing bonkers things. And we can, if we wanted to, let's actually assign this to something. So let's complain, let's call it n, it's equal to map, and we can build it straight off. So we can turn around and we can say that 1 is, actually let's do even more silly. Do it like that, I have a string int. Now you'll notice I have 2 errors. Error the first, m is wiggly underlined because I'm not using it. That is not allowed. So let's get rid of that one. The other one here is because I don't have a comma. You have to have the trading commas in Go. Now I disagree with this. I've spent most of my programming life not having the trading commas, but my opinion doesn't count here. It's the compiler that counts. So it is useful insofar as I want to add another entry. It's not too hard to forget that you need a comma, although the compiler would turn around anyway and tell you you're missing a comma. So we have ourselves a map, and in fact, if we just print that out as is, this is just the internal representation of the map. And we can do our standard sort of mappy type things. We can turn around and pull out the value at 1. And we can range across them as well. So we can say kb equals range n kv. Oops. And hopefully no surprises when it does that. So if is similarly unsurprising. No braces. no parentheses even, but otherwise it works as expected. And if you want to put an else or an else if on there, you can shove that on there. So we've got most of the sort of the basics of the language going. We can define our own functions. This possibly won't with the way I've set it up. There are tools that when you run it across, it'll whinge. There's a tool called go format, which formats your code the way it needs to be formatted. Although I use go imports, which is like go format with all the dials turned up to 13. Then there's go lint and go vet. And you run those across and it will start complaining about stuff like that. So we can have, let's just get rid of that. We can have our user-defined functions, func foo, because of course we're developers and we can't think of names, and we can format or print them bar, and then we can call that from here. Oops. No surprises at all. If we want to return something from there, we could turn around and say actually the foo returns a string, and then we can return foo in this case, and then we can format or print them foo. And again, no surprises. But I've said we can return multiple types. And if we want to do that, we actually need to put the return types in parentheses. Now this will work because printman will accept more than one thing. But if I was to do this, it will now complain because I'm trying to get 2 values and only assign it to 1 value. So in this case, I've got I might want to do it that way around. Okay, so functions nice and simple. If we want to take arguments, we can put them in. So we can turn around and say we've got a bar and it's a type string. You've probably noticed that your type declarations are in the wrong place. Bouncing between languages like this can be fun. Again, it's just something you get used to. If you have more than one parameter that shares a type, you can in fact do this. So you go bar and baz, they're both strings, but if bar happened to be an int, you would do it that way. We're now whinging here because we need to pass in arguments. Cool. So let's start getting a little bit more funky. Let's actually go off and create ourselves something that is not in the main package. So we will again call this foo. My ability to name things off the top of my head is limited. You go file foo.go. Excellent. So we're now in package foo, and we want to define a function that is external to the world, so that other people can use that package, and that will. Oh, right. So I can import that into this. That because that's going to confuse it. Now you'll notice my import's now quite big. Before we had format and stuff like that, it was quite small because they're the standard library components. This is now part of my my package, so it's going off and using that full name that I defined when I did the go mod in it. And this allows you to effectively namespace your code. No, not this way. So when Go first started, you would go off and you would pull stuff from GitHub and everything, because everything is open source and we always use the latest version of the code, obviously, which was a bad idea. So then we got vendoring, which allowed us to turn around and say, right, we want to take these dependencies and we're going to pop them in a vendoring folder, and that is the set of dependencies, and we can check that into source code control and be happy that we're going to have the same version each time we build which was okay, but had problems. And there were also issues if you're going off to private Git repositories, which a lot of us tend to do. So Go modules is a relatively new thing which allows us to turn around and say, actually, this is a module, this is the dependency that I have, and this is actually the revision or the commit that I need to pull that dependency from. So you can specify where it's being pulled from in that Git repository. But it's not as simple as turning around and saying, right, I want this branch on the import. Right, this should run nicely. Bar, bam. Right, let's introduce some types. So we're going to have type foo. So there's two different types of type that we can define. I'm just going to actually define this as a string type, and then we're going to have a var is and use imports are not allowed either. So what we're doing here is we're turning around and saying we've got a type of foo, it is actually a string. We're defining a variable called bar, which is globally visible to the world, and we're saying that is of type foo of string. And then we've got a baz that returns foo. But one of the things we can do here now is we can turn around and we can say the bar is actually only visible within this package. So I have now got something that is defined locally, defined within a set package, and then exposed to the rest of the world via a function. So I can make sure that actually my type is correctly constructed. And this becomes a lot more important when your types are of type struct, because at this point you can start building really quite complex data structures. So in there we can have a bar of type string and a baz of type string. If I pass this foo out, I'm going to be able to reach in and get hold of the bar, but because the baz is private, I can't get hold of it. So there's actually no way for me to set that other than it being set when it's created, which could be problematic. So we can actually that's fine timing. I'll get rid of that. We can hang functions of a type. So we can turn around and we can say that func, and now we have a little piece of syntax that just turns around and says this function lives off type foo, and the type foo that it's attached to is assigned to f. You can actually use anything there, but idiomatically we use a single character, the first character of the name. Let's call it baz, and we will take a string s, and we can do f.baz equals s. Right. So over here, we're going to give ourselves something of type foo.foo. And we can set bar, because we can see it, and we can print that. Oops. We get our type. Now the space afterwards is goes representation of the type, so not of the struct. So we've got an empty string. It puts a space between the arguments, so you've got the hello string and then the empty string. So now what I want to do is do f.baz and set that to world. Any guesses for what I'm going to get? I still get hello. Now the problem here is that this is acting on a copy of foo. So we're not passing by reference, we're passing by value. So f gets copied, and we dutifully take f, and we set bounds to be the value of the string, and then that copy gets thrown away. What we actually need is a pointer to foo. Now, we get hello world. Because we've passed in a pointer, we're now actually fiddling with the object or the struct that we've got. Now the great thing about doing this here is I don't have to explain pointers to everyone. Good. And they're much simpler than pointers in C and C++ insofar as you don't have to worry about allocation or anything like that. It's just there is a pointer, and you can either say I want to point it to this or I want to dereference this. There's very little else that you do with it. And the semantics is very much the same. So I can, if I want to, turn around and dereference f if I want to, or I can get a pointer to f dot baz. Sorry, is they? Yes. You don't worry about any of that. The language does all of that for you. So this is pointers light. I know. If I care to that level, this is the wrong language. Yes, there's a garbage collector that does stuff in the background. If I want to do grown-up programming, I'll go use a grown-up language. This is it gives me training wheels. I can pretend I've got pointers.
There's no lifetime issues there.
Yes, so you will. Things are handled by the garbage collection, and there has been some controversy about the Go garbage collector and whether it's good or not. And depending on how you want to set up your example, you can prove that it is either fast or not fast, but you can do that with any garbage collector. One of the things you can actually do if you're worried about what's going on in terms of letting go of things, this happens more with if you're dealing with things like files and stuff like that. If you want to close a file, let's change this so this now returns an error. There is an error type in Go. We return errors rather than throwing exceptions or anything. And we can turn around and we can say that if s is equal to the empty string, we're going to return why are you not liking that? Oh. Stupid third-party packages that no punctuation. And then we can turn around and we can say we'll pretend that we've got a file string. We'll pretend that's something slightly more important than a string that we need to do something with. So we've got this keyword called defer. And we can say that when the function exits, go run some code. So I'm actually just going to define a little lambda here that just turns around and sets file to foo, and then we can run that. So I know that actually. That way, and then oops, just stop it from whinging at me. And the same here. One of the problems of the compiler being so strict. So what we're saying here is that we're going to set the value of this variable to be hello. When the function exits, we will perform this action. Then we've got a thing here that says if our input string is empty, we can return an error. Then we're doing some stuff. The last thing we need to do is just return nil. So although we're throwing it away, file will always be set to hello at some point, either here when we return with our error or here when we return straight away. So if you're doing something that requires closing or cleaning up or something like that, if you've got file handlers, you can open the file, bang in a defer, and then don't have to worry about the fact that you need to remember to close it in every single case of error handling. And part of the reason that's useful, if we turn around and go back here, this is now complaining at me because I've got an error that's been returned, but I'm not doing anything with it. This is actually just a linter warning rather than a compiler warning. But you will see this pattern all over the place. Now, there's a few things going on there. The if block allows us to effectively do some evaluation, an assignment, and then check the contents of that assignment in a single statement. So we're turning around and saying, right, let's grab our error. If our error is equal to nil, do something with it. The other way that we can do this is just the good old-fashioned if error not equal to nil. And you will find in certain pieces of code, you've got line of code, if error not equal to nil, do something, line of code, if error not equal to nil, do something. And if you need to remember to close your file or your database connection in every single one of those blocks, it's not great. So the defer is useful. Yes, that's actually a very good point. If I do it this way, error is scoped to just the if. So if I try and print it out there, it doesn't exist. So there's just basically some temporary variables. So. Oh, you've spotted a bug. That's why I've had to put the full mode.println in twice. Very good spot. I should have done that. And what I'd done there is I'd shadowed the variable. So your closures, as you would expect, can see variables outside of their scope and it gets closed around. But you can also do that where you eclipse a variable. So I turned around and said, hi, this is a new variable, it's a new scope. And the compiler will let me do that. And yeah, I should have actually spotted that when I was going, why do I need to print line twice? Because it was used, but actually, no. So Go is a simple language, but it still doesn't save you from yourself. There are various things that you can do in order to shoot yourself in the foot. But then that is the same with every language. Right, so the other type that we have is the type of interface. And this is very sort of Python-esque insofar as you define interfaces in a duck typing way. So if I turn around and say this has bars of string that returns an error, foo is now of type I, despite the fact that I've not done anything to foo, because what we're saying is anything that matches this pattern, matches these method types, is of this type. It's quite useful when you're doing testing, and also gets around a little bit the fact that you don't have generics in this language. Yes. No, it's all statically linked. So that is a valid interface declaration, which actually means anything. So this will match everything. Annoyingly, let's go down here. So I'm taking in a slice of interface, and I want to try and cast that to a slice of string, perhaps. There's no way I can easily get from this slice of interface to a slice of string. If it was just that, I could turn around and say, actually, it's just it's a string. Now that will blow up at runtime if it isn't, and there are ways around that. You can actually turn around and if you put an OK, idiomatically an OK, it's actually a boolean. That changes the behavior of the casting and says that actually if the cast fails, don't panic and die. Return me back a false. So you can then turn around and say, actually, this is not the correct type. Which, with the lack of generics and everything, means that you interface with nothing in it seems a little bit kind of useless. But there are things you can do with it. So we have this idea of a type switch. Let's make it slightly easier to read. And we can turn around and we can say switch on I equals I dot type. And then we can turn around and go case string. So what's happening here is we're saying basically try and cast the type, try and cast the value that we have, and if it is one of these types, if we match, then where we are down here, we're actually handed something that has been cast to that type. Now, one of the nice things that the go case statements allow you to do is you can actually put more than one match. So I can turn around and say if it matches in 32 or in 64. But the problem is the type switching no longer works properly because the compiler, well, at runtime, has no idea what type you want that to be. So this actually still comes through as an interface. Yes. I have a solution for that. I mean, I switch between this and JavaScript quite a lot, and that's and also C#, and it's just a nightmare.
It's always out-of-box somewhere in the function level, or always they are allocated on the key, because I see it might end up being an int. This kind of implies it's some kind of base object which has like a virtual table attached to it or something, or type information.
Honestly, don't know. All of this detail is like way too low level for Go developers. We don't get that's part of the reason we're using this language is because we don't want to care about this stuff. We are operating on machines that have enough CPU and enough memory and everything that we don't really care about. Yeah, it's.
So you can afford to allocate each byte of the heap. Okay.
If it gets allocated where it gets allocated, it runs fast enough. Again, if you're doing something that's time critical or anything like that, this is not the language for you. This is something that's actually quite useful to wrap up and shove into a Docker container and do things with. It is fast. It's not as fast as C or C++. It's never going to be because you can't hand optimize things, but it is faster than other sort of comparable languages because it's nicely compiled down. And then this is the main reason why I like it, is because you can hold most of the language in your head, and you can actually get new developers to come up and pick up the code that you've written very quickly. And while you can shoot yourself in the foot, you need to try a little harder, and it's easier to pick up and it's easier to spot the mistakes and how perhaps you should be doing things. It also gets rid of the team arguments about how you're going to do things like formatting. There is no argument. It's done this way. So it's one of those things. If you want tight control over things, then go to C, C++, or assembler. You know, or as Kevin said, go down to the firmware level. Right.
I would put them in the same category, but I guess it depends where you.
Yeah. You know, this is aimed at sort of the JavaScript generation. Let's put it that way. Try and convince myself that I'm young. So, if we go back to defining our interface on here, which has where are we? It's a function baz with a string and an error. So, if I was to here, it's never going to do anything, so we can leave that. %t just prints the type. So we can have a look and see what type's coming out. And, let's use the correct format of it. Now, despite the fact it matches that interface, it's not of that type. So when we ask it for its type, it actually gives you the concrete type that it is. But I can turn around and I can define myself a function that takes a type of I. I hope if I could spell. And then down here, if I create myself a foo, and then I can pass that into whatever. Create myself a foo, and pass that into whatever. So the compiler is relatively smart. It will try and work out what types are, and it will try and work out whether you're wanting to use a pointer function or a standard function. But occasionally you do actually need to be quite explicit. So in this case, because I've got pointer functions, it wants a pointer to the type. So it's a fairly basic type system. It's very C-like in the fact that you've got your structs and you're hanging things off there. We don't have the generics. We don't have sort of inheritance and things like that, but we do have composability. So you can start defining things in terms of themselves. So I can have big foo, which contains a foo, and then I can put other types on there. So I can start composing things out. And big foo is going to be of type I now, because it's inherited all of what I inherited is being composed with everything that foo had. And I can also tell it this is just an anonymous thing. This wakes everything up to the top level, so I can do big foo dot and then whatever's on foo. But I can also give this a name. So I can do that because it means I can then control the scope on it. I can turn around and say, actually, you don't have access to that particular thing. And using this kind of composability, you can then build up some really quite complex data structures if you wanted to. So we have a custom driver for the database that we use. And the result structure that comes back is some really quite nasty JSON. And we're mapping that JSON onto a Go object type. And then taking that hard to navigate object and actually translating it into a different object type, which again is quite complex, but is much easier to traverse, and it's several levels deep. So you've got structs that contain other structs, which contain slices, which contain maps. And you can build up all the tools that you need to build most sort of applications. We finish at 4, don't we? We have 3 minutes left. So I've only given you a brief taste of what Go looks like, what it can do. There, like I say, there is the online Go tutorial, which let's. Yes, and you shouldn't need to use it. So a tour of Go. Oh, so serialization we tend not to do. Quite a lot of the time, if you want to spit things out, you'll spit them out as JSON or XML, and there's excellent support for actually going straight from a Go object to a JSON object or an XML object and back again. If you want to serialize, you can. There are serialization functions and stuff like that you can also do. But I've got a sneaking suspicion that you're going to want more control than Go can give you. But this tour of Go is really comprehensive. And the other thing I've noticed with this language, with most languages, 90% of my answers for help come from Stack Overflow. With Go, only 50% come from Stack Overflow. 50% actually comes from the documentation because it's pretty good. Anyway, hopefully that's been reasonably informative for you. Thank you for coming along, and I'm now going to have to read up a lot more about the internals of Go. Told you I'd learned something. Thank you very much.